Hello everyone, this is the tutorial for Matlab. Matlab means matrix lab, which means the data structure for Matlab is matrices, so it can do matrix operations conveniently and quickly. So first, let's create a 3 by 3 matrix. For example, A equals to 1, 3, 4, 3, 5, 9, and minus 3, minus 8, 0. It means the first row is 134, the second row is 359, and the third row is minus 3, minus 8, 0. So you can find some elements for A. For example, if you are supposed to find the element at the second row and third column, just A to 3. So you can say that's 9, which is this element. And also, you can find the elements for the first column. So it means any row in the first column. So it means the first column for A here. Just type in this guy. And also we can create a vector in R3, which is a 3 by 1 matrix. So for example, D equals to 5, 6, and minus 2 here. So it is a 3 by 1 matrix, which is a vector in R3 here. And also we can find the element in D here. For example, the third element D3, which is minus 2 here. Also, matrices and vectors can be loaded from files. So first, let's search the path. So here, document, lecture notes, and Matlab. So now the file is selected from this folder. We can load any file as you want. For example, we can load demo.mat. So here, load demo.mat. So any file in demo.mat is loaded. For example, BC and large 1, large 2 here. So we can, after loading some matrices, we can show you some matrix operations. For example, we can add two matrices, A plus B here, and also minus two matrices, A minus B, and also matrix multiplication goes to A times B. And also we can multiply the two matrices element by element. So we can say multiply 2 equals to A dot multiplied by B, which is the multiplication of each element. For example, this 3 is the multiplication of A. So in the first row and second column, and also B in the first row, second column. So 3 times 2 equals to 6. So that's the difference between the multiplication and the dot multiplication here. And also we can use some functions for matrices. For example, we can find the determinant for the matrix. So determinant of B, just det B, and also the inverse of B here. If you want to solve linear systems, for example, you are supposed to solve Bx equals to C. You can use x equals to inverse of B times C here. So that linear system is solved. But there's a better way which is x equals to b, left divided by c here. So the results is the same, but this way is more convenient and more efficient. If you use larger matrices, it is much faster than use the inverse. And also you can find the eigenvalues for matrices such as m f equals to eigenvalues of b. So here F is a 3 by 3 diagonal matrix and each element is one of the eigenvalues for the matrix A here. And M is the 3 by 3 matrix with the three eigenvectors. So the first column is the eigenvector of B corresponding with the eigenvalue 0.2207, and the second column is the eigenvector corresponding to this eigenvalue. Third column is eigenvector corresponding to this eigenvalue here. And also you can transpose one matrix. For example, B transpose is just the transpose of the matrix. That's for real matrix. If the matrix has some complex numbers, prime means the conjugate of the transpose. And if you just want to transpose one matrix, you can use dot prime instead of prime. So for example, we create a complex matrix 3 plus 4 times I. I just means the basic element for image numbers. And 6 minus 7, 8 times I. Sorry. So that's the 1 by 2 matrix. And if you only use prime, it is the conjugate of the transpose. And use dot prime, that's the transpose without the conjugate. So that's the difference between prime and dot prime for complex matrices. But for real matrix, these two operations are equivalent. Like other programming languages, you can use the loops, so you can use for loop or while loop. So let's have for loop for the example. Assume you can multiply the two matrices element by element. First way is as the previous way, use the dot multiplication. So for example, large 3 equals to large 1 dot multiplication of large 2 here. So large 1, large 2 are both 3000 by 3000 matrix. So large 3 is also 3000 by 3000. Now you can use for loop. So for k equals to 1 to 3000, for h equals to 1 to 3000. Remember, I and j sometimes means the complex numbers in Matlab. So avoid using I or j in for loops, just use k or other letters. So we can use large for the kth row and h column as the multiplication of large 1 kth row and h column multiplied by large 2 kth row and h column, and use n at the end of the for loop here. So you can see it is busy. It means the operation is processing here, and we have to wait some time for the operation. You can Now the operation ends. You can see that the same operation, if we use the for loops, it takes much longer time than use the matrix form. So for Matlab, we strongly recommend you to use the matrix and vector form and the functions for matrices and vectors instead of using the for loop, because using for loop in Matlab is extremely uh, slow, which is quite different from other languages. And Matlab has some functions for plot of the graphs. For example, we are supposed to plot sine of x from 0 to 2 pi. So first we need to create a domain x 0 and the interval is pi over 12. Pi means and 2 times pi. So it means it starts at 0 and each the length for each interval is pi over 12 and x ends at 2 pi here. And y equals to sine x, it means y equals to sine x for each element here. And we can plot x and y. So that's the plot of sine x from 0 to 2 pi. Now we can plot two curves in the same graph. So for example, we can use z equals to cosine of x and plot the curve for sine x as the red curve. And remember, if you want to plot the two curves in one graph, you need to use hold down and plot x and z for the blue curve. So you can see the sine curve is the red curve and blue curve is the cosine curve. And you can insert some legend here. So it is the sine curve and it is cosine. And also you can insert the XY label and title by yourself. Now we can save the plot here. So save it as, for example, sine cosine, and you can choose the file type. For example, we want to save an EPS file. So the file is saved as sine cosine.eps here. Now we can use some image operations of the Matlab so it can do some interesting image processing tasks. For example, we want to load the image for trump.jpg in this folder. So you can use im.imageRead trump.jpg here. Oh, so you can see the image contains three matrices. Each matrix is one layer of the image. So the first layer is the red layer, the second is the green, and the third is the blue layer. So you can use some operations for it. So for example, we want to transform the color image into the grayscale one. So you can say image2 equals to, for example, 0.1 times the first layer plus 0.7 times the green layer. So and plus 0.2 times the blue layer. So image 2 is the grayscale image. We can show what it looks like. So image 2, we can see it is the grayscale image of Donald Trump. And we can save the matrix image 2 here. So the first way to save it is to save it as the Matlab file, which is .mat, which is just a matrix. So we can use save image to the so jump to the mat, and the name of variable is image here. So now the matrix uh, image is saved here in jump2.mat, and also we can save the image in JPEG file, and you can use the operation image write. But now I forgot how to uh, use the function image write. But don't be nervous about it. You can use the help to do it. So help image write this function. So it is the document for image write, and it have so many descriptions. So a file name fmt. Uh, so a can be a image, and the file name is a string, and fmt key is also a string, and you can see many other kinds of justification for this function. If you even don't know the function name image write, you can search it online. So for example, Matlab save images. So you can click on the link for MathWorks. So it is the documentation of Matlab, and it also has the description for the function, and the description for what each variable means. And it also has some examples. You can find most examples here. It is pretty official, and the write is pretty clear. So you can find help by yourself, which is quite important because you cannot know every function in Matlab. If you forget or don't know how to use it, simply use help or to find it online. That's very convenient and very efficient. So after using help and looking for it online, you can use the function image right here. So here we can use image write. So image 2 and the file name chunk2.jpg. So now the file chunk2.jpg is saved in our folder. And Matlab have some very interesting functions you need to discover by yourself later. And I hope you enjoy it. Thank you.